Okay, folks, we're going to be on page 23. Anyone still writing the quiz? You're okay, though. All right, good. Page 23. Page 23. Okay, last time, if you recall, we started with a sodium atom and a chlorine atom. So an atom of sodium and an atom of chlorine. What type of element is sodium? It is a metal, yes. And chlorine is what type of element? It's a nonmetal. And when you put a metal together with a nonmetal, what type of compound do you get? Tell your partner. Metal plus nonmetal. A metal plus a nonmetal is what type of compound? Yes, ionic. And if we had a nonmetal plus a nonmetal, that would be covalent. And in an ionic compound, what happens to the electrons? Yes. Yeah, the metal gives electrons, the nonmetal takes electrons. So metal and nonmetal is an ionic compound. The metal gives electrons, the nonmetal takes electrons. Okay, now nonmetal plus nonmetal is covalent. Whoops, I should say covalent compound. Gives you a covalent compound. And a covalent compound, what do the two nonmetals do with their electrons? They share electrons. What kind of structure do we get when nonmetals bond covalently? We get a type of particle. Yeah, we get a molecule. Okay? Now we have a metal that gives electrons. What does it become? If a metal gives away electrons, it becomes an ion. What type of ion? Cation. And what charge are cations? Cations are positive. And the nonmetal takes electrons. What does that give us? That gives us an anion, which is negative. And when we put that looks weird. When we put a cation and an anion together, what does that form? That's a different type of particle. That one's tricky. It is a compound. This is an ionic compound. But what is that particle called? It's not a molecule. What are the 4 types of particles? See if you can remember with your partner. What are the 4 types of particles? Formula unit. Oh, yes. So formula unit is one type of particle. Atom. Molecule. Yep. And you know what? I get really tired of writing molecule. So my abbreviation for molecule is capital M, capital C. Okay? We're not going to abbreviate it MOLE because that means something special in grade 11 and grade 12. Okay? So we're going to do it MC for molecule. Alrighty? And we have a 4th type of particle, which is an ion. Very good. So if we go back over here and we see that we have a positive and a negative together, that is called a formula unit. And I'll be honest with you, there is an abbreviation for formula unit, but I don't want to say it out loud because it sounds rather improper. Oh. But if you want to write it, you can, but I will not say it out loud. Okay? There we go. Oops. Okay? There's no other good way to abbreviate it, so there we are. What can we do? All right. Okay. So here we have our sodium and our chloride. What does sodium do to chloride? If I was to label the process of forming a compound between these two, what would I have to draw? Not yet. Before I have the chemical bond, I would have to draw, what does the metal do? The metal gives an electron, and the nonmetal takes an electron, and what we end up with then is we end up with Na plus and Cl minus. Now we can do one better than just showing whose model of the, that jumped around a lot. Whose model of the atom is this? Whose model of the atom is this one? Just the sphere. That's a Dalton model. Oops, those letters went a little crazy. We can do one better than that. We are going to go and we are going to do a Bohr model instead. Okay? So sodium has, its atomic number is 11. So that means it has 11 protons. And you can see in the nucleus we have 11 protons. We're going to ignore the neutrons because they don't matter when we're looking at ion formation because they don't have a charge. So we'll ignore the neutrons because they don't have a charge. Chlorine, on the other hand, has 17 protons. And if you were to count up all the electrons in sodium, you would notice that it also has 11 protons, which gives it overall a 0 net charge. Chlorine, 17 protons and 17 electrons, has a 0 net charge. What do you think is going to happen with these two little diagrams here? Take a look at the purple electrons. Take a look at the green electrons. Tell your partner what you think is going to happen. What's going to happen? Yeah. Yeah, sodium's purple electron is going to come over here and slide right on in to the chlorine. One electron is transferred. Okay, and they're showing that down here. One electron goes from sodium to chlorine because what do atoms want? They want full or complete outer, whoops, I can spell outer, sure I can, outer shells. Oh, that's where the S came from. It came from shells. Okay. I was like, why? Now, how many protons does sodium have? Did it change the number of protons?
No.
Or do we have the same number as before? Let's take a look. There's the protons. There's the protons. Did we change the number of protons? No. What would have happened if we changed the number of protons? Tell your partner. Yeah, you would get a different element. So we don't want that to happen. We still want it to be sodium. And you'll notice we started with 17 protons for chlorine and ended with 17 protons. Those have stayed the same. We still have 11 and 17. How many electrons left in sodium? 10. So we have 11 positives and 10 negatives, which leaves us with an overall +1 charge. And what would we need to include on our Bohr model if we were doing this properly? It has now lost an electron. What should we do with this Bohr model that now has a charge? Brackets. And where does the charge go? Top right. So we'll put our plus up there. You could write +1, but plus will work just fine too, okay? I'm going to unhighlight that now. And chlorine has gained an electron, so instead of having 17, it has 18 electrons. So overall, it is, what's its charge? -1. Okay, so overall, it is -1. And so we're going to put brackets around that as well. And we'll put a negative up at the top. Oops. What do you notice about the overall charge? We have a +1 and we have a -1. What happens if we add those two together? What do we get if we have the sodium and the chloride together? Charge is 0. And what do we call this compound here? It's an ionic compound, and its name is sodium chloride. Is good? Okay, excellent. And now there's a few questions here. Do you guys want to take a few minutes and do these? These are page 24. So take a few minutes and do page 24. Yes. Oh, and by the way, I know Tyler doesn't pair up his electrons. When you draw your diagram, you can show the electrons pairing up, okay? What equation charges? You're really, really close to speed. Abstraction between the two charges. Okay. Yeah. And if you want to get even better, you will electrostatic it. Same thing. Folks, I'm going to give you a hand on number 2 because you probably don't remember it. The actual ionic bond, you probably know that it's an attraction, yes, between the positive and negative. But I'm going to give you an extra word. It is the electrostatic. And then I ran out of room, so I'm going to have to write attraction. Between opposite charges. If you got attraction, that was pretty good. If you wrote bond, that's not bad either. Basically, yeah. Anyone else need a periodic symbol? Something else. Yes, Bohr. Oh, for number 3. Guys, for number 3, you are not doing sodium and chlorine, you are doing lithium and fluorine. So it's going to be just a little bit different and a little less complicated, actually, because they have fewer electrons. So you are going to start with a Bohr model for lithium and a Bohr model for fluorine. Show the transfer of the electron, and then show the Bohr model for lithium and fluoride. Okay. Yes. I don't know where the flash has gotten to. He's hiding. So if you're not sure what to do for the last question there, you're going to draw the Bohr models for lithium and fluorine, show the electron transfer, and then show the Bohr models for the lithium ion and the fluoride ion. Okay. Very nice.
But I kind of tried to double check.
Uh-huh.
They have the dogs like this.
Oh, no, that doesn't. You're better. Yeah, yeah. Actually, really. Sure. That's nice.
It's like,
Yeah.
yeah.
Needs fixing. Okay. Okay.
These guys don't share all this. So basically what you have is first, you know, the side, positive, negative. No, that's fine. Just to make sure.
All right. If you had your phone out because you were finished, you can now put it back in your bag. And we are going to look at page 30. All right, friends, do you remember where you would find your metals on the periodic table? They are on the left side. Where are the nonmetals? The nonmetals are on the right side, except for who? Hydrogen. Hydrogen is kind of funny, but mostly metals are on the left, nonmetals are on the right. So we are going to be looking at writing the names of some ionic compounds and the formulas of those compounds. And just like on the periodic table, the metal goes on the left and the nonmetal goes on the right. So if you're naming it, you'll notice sodium comes first, chloride comes second, metal, then nonmetal. Okay? And even when we have two nonmetals together, we'll still usually write the nonmetal that is furthest to the left first and the nonmetal that is furthest to the right second. Okay, there's a little bit more to it than that, but that's pretty close. So the metal always comes first, and it goes on the left. This is page 30, if you're not there yet. And the nonmetal always comes second, and it goes on the right. just like on the periodic table. And you guys have already started naming some ionic compounds. The simplest ionic compounds, we just name the metal. Name the metal. And then the second thing we do is we name the nonmetal, but with the nonmetal, because it is an ionic compound, it's made of ions. What do we do with a nonmetal ion name? Ide. Okay? So if we have a compound between magnesium and oxygen, what would we name that compound? Magnesium oxide. Magnesium keeps its name. That's our metal. Oxide. I don't know what's with my X. That's a weird X, but that's okay. So the metal goes first, and the nonmetal ends in ide. How many syllables for our nonmetal? 2 syllables. Nonmetal ions generally have 2 syllables. So not oxyide, not oxyide, oxide. A compound forms between nitrogen and aluminum. Is nitrogen a metal or a nonmetal? Nitrogen is a nonmetal. Aluminum is a metal. So who has to come first? Does aluminum come first or does nitrogen come first? Aluminum, because it is a metal. So this one goes first, this one goes second. So it's going to be named aluminum. And now I'm going to give you some choices. Which name do you like? Tell your partner. Is it aluminum nitrogen? Is it aluminum nitrogide? Is it aluminum nitride? Nitride, because we want 2 syllables and we want the ending ide. So it's neither of these. This is the correct one. Okay, good. Now, formulas, you should be a little bit familiar with these. We have been looking at these little subscripts. Have we talked about this word yet? Maybe not. Subscript. Sub means below. So if you go in a submarine, you are going under the water. Okay, so sub means below. And script means writing. So if something is a subscript, it goes below the regular writing. Subscripts are those small numbers written at the bottom of an element symbol. So let's say, for example, I had, what's a good one? C12, H22, O11. Those little tiny numbers there, down at the bottom, those are subscripts. That right there is the formula for table sugar, if you're interested. There's 12 carbons, 22 hydrogen atoms, and 11 oxygen atoms. That's what that means. It means we have 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. However, what if we have only one of an element? Do we write anything? No. So H2O, the 2 is the subscript that tells us there are 2 hydrogen atoms. But with the oxygen, there's no subscript, which means there's only 1. So you can see how many hydrogens do we have? We have 2 hydrogens. And we have only 1 oxygen. I'm going to put that O further away from the 1 because it looks like a 10. Excuse me. How many atoms of each element are there in this molecule? I would like you to write those down and then check with your partner. NaC2H3O2. How many NAs do we have? Because there is no number there, we have 1. How many carbons do we have? Everybody, how many carbons? Carbons are 2. How many hydrogens? 3. How many oxygens? 2. Let us draw a formula unit made of 1 calcium ion, Ca2+. So we're going to write Ca2+, and 2 chloride ions. What would I draw here? That would be Cl minus and Cl minus. And that, remember, is a formula unit. And it is a formula unit because what type of compound is this? It is made of ions. What type of compound is it? It is an ionic compound. Okay. What is the formula for a compound made of calcium and chlorine? See if you can tell your partner. Quick, quick, quick. Formula for this compound. I'm going to give you a few choices. Which one do we like? Do we like option 1, option 2, or option 3? 3, because our metal has to come first. What is the name of this compound? See if you can figure that out. Tell your partner, and then give its formula. Name this compound, then give its formula. So this compound is made of sodium and phosphorus. Na is sodium, P is phosphorus. So which one would come first in the name? Sodium, because that's the metal. So the metal comes first. And the nonmetal comes second. Is it which one is it? Phosphorus, phosphoride, or phosphide? Phosphide, 2 syllables, not phosphoride, 3 syllables. So we always want to just have 2 syllables, so phosphide. What is the formula of this compound? Na3P. The metal comes first, the nonmetal comes second. We have 3 sodiums and phosphorus. What is the total positive charge in this compound?
48.
What's our total positive? We have +1, +1, +1. Total positive is 3+. What's our total negative? 3-, right? We got 3-. What is the overall charge of this compound? 0. Nature likes positive and negative to be balanced. Therefore, the net charge of every compound must be 0. Don't forget, the first letter of element symbols is always a capital, and the second letter is always lowercase. Shh. How many elements in KF? 2, capital, capital. How many elements in MgBr2? 2, capital, capital. How many elements in NH4Cl? 3, N, H, and Cl. How many in NaNO3? 3, 1, 2, 3, 3 capitals. Shh. And just so you know, this, is that Cl or Ci? That's Cl. Not Ci. I will always put a crossbar on the top and the bottom if it's an I, okay? Just to make it really clear for you. Here we have a molecule, Cl2, made of 2 Cls. What kind of a bond is that right there? What is it? That is covalent because this is a nonmetal and a Non-metal, so that is a covalent bond. What type of particle is that? That is a molecule, yes. Ki is an ionic compound. What kind of a bond is this right here? Ionic. Super difficult, right? Ooh, look. Here is a Ci4. Do you see how the I has crossbars at the top and the bottom? Ci is made of 4 iodine atoms bonded to 1 carbon. Is iodine a metal or a non-metal? Non-metal. Is carbon a metal or a non-metal? Non-metal. So what type of compound is this? This is a covalent compound. What type of particle is this? Is it an atom, a molecule, a formula unit, or an ion? That's a molecule. Speaking of which, what type of a particle is the K and the I together? That is it's a formula unit. And all I'm going to have you do for homework is number 1. That's it. Okay? Number 1 on page 32. You can probably finish it right now and not have anything. You just need to name the compound, but remember, put the metal first. I might not have put the metal there for you. Okay? So you have to put the metal first and change the non-metal ending to "ide." So your homework, page 32, number 1, you can probably finish it right now, unless you've already put your books away, which was a foolish thing to do. No, that's the afternoon class. Yeah, I know it's confusing. Yeah, lunchtime starts at 41. Question 1.